So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be using Parseval's identity, and that too for this given credentials, you can say. And I will promise you guys, I'm promising you guys that we would be reaching at an amazing point after using all these things actually. And yeah, even I have used Parseval's identity once in my older videos actually. If you want, you can check that out. But now, yeah, let's just talk about this. Okay, so basically I have written, look, let me just explain you what the Parseval's identity is all about. So Parseval identity is if you have if you have two distinct functions, actually you can say two distinct periodic functions actually. Right? And bounded between a negative L to L, you can say. So that's gonna be helping us. Look, you have your f of x and g of x. Let's say these are the two functions. So look, your f of x is a function and g of x is also a function. Distinct, although those two are distinct functions actually, periodic functions. So if we talk about this coefficient, actually a sub n. So a sub n is 1 over 2l times integral from negative L to L of f of x, the first periodic function, and e to the I n pi x over L dx. And if you talk about b sub n, so it's gonna be 1 over 2l and times integral from negative L to L of g of x. Now considering the second periodic function, wait a second, yeah, and it's e to the r n pi x over L dx. Okay, so yeah, we are just here that so far. And so basically you have to calculate all these things. You have given this function f of x, you have to plug that over there and you will get some a sub n and b sub n, and using those things, this is the actual Parseval's identity that says the sum actually from negative infinity to infinity of a sub n and the conjugate of b sub n actually equals 1 over 2l times integral from negative L to L of the first function and times the conjugate of the second function dx. So this is your Parseval's identity, right? So yeah, that's this is what the Parseval's identity is all about. And yeah, actually I need to check that out. Let me be frank here. Actually, I'm just thinking that I have made that video on this only, so I need to check that once and then I'll just get back to you. So let's just give me a while. Yeah, guys, I just checked that video out, and guess what? That video is different. In that video, I just took f of x as tangent of x, and I think g of x as cotangent of x, and that too from negative pi over 2 to pi over 2, I think. I'm not sure, but now let's just talk about this. Okay, so yeah, basically this is our f of x and g of x, and let's just play around with this using these things. Okay, and it's not the final Parseval's identity, guys, because these are the things which we are gonna use. That's why I'm just explaining you what are necessary for this video. But maybe for upcoming videos, I'm just gonna use the final and the exact Parseval's identity to just get to reach up to something crazy result actually. You know what? I was just solving around with this. and I just got a result which will break your thoughts, like which will lead you to just think about this once. And that result is itself, oh my goodness, I cannot explain you in this video, but I'm sure that I'm just gonna bring that for you in some upcoming videos. So okay, now let's just talk about this because our time is going on. Okay, so basically let's calculate a sub n firstly, right? So we know that a sub n is, and since our L, this is your L, that is pi, so your L is pi. Let me just write that down for you guys, don't get confused. For this case, our L is pi. So a sub n is integral from, 1 over 2 pi L and times integral from negative pi to pi, and f of x is e to the I x and e to the, and since L is pi, so it's, look, I n pi x over pi. Pi cancels out and we are left with I n x only. So I'm just gonna consider that one directly. So basically it's I n x and it's dx, right? Okay, and now if we just talk about the integral of this one, so it's pretty easy and it's evaluable easily, because this can also be written as a sub n equals 1 over 2 pi times integral from negative pi to pi, and we can combine the exponents of e as ix plus I n x dx. And now we can isolate the I and x. We can just factor out I and x from this exponents over there. So a sub n is 1 over 2 pi integral from negative pi to pi e to the I 1 plus x, 1 plus n and times x. And we know that the integral, look guys, look, let me just evaluate this for you. Okay, but you just need to know that the integral of e to the x is e to the x plus c. So you just need to know about that. So basically for this integral, I'm gonna just plug I times 1 plus n x as t. That's pretty fine. Okay. Okay, so yeah, if we talk about limits, so when you plug x equals pi, so that's gonna be I 1 plus n pi, and if you plug n equals negative pi, so it's negative I 1 plus n pi, right? And if you talk about the derivative, so dx, since I times 1 plus n is a constant with respect to x and with respect to t as well, so the dx is gonna be dt over I times 1 plus n, right? So basically if we talk about this integral, oh, my hand will not, okay, so yeah, we are having this thing. So basically our a sub n is gonna be 1 over 2 pi as we had factored earlier, and the limits are from negative I 1 plus n pi to I 1 plus n pi, and it's, since this we have considered this exponent as t, so it's e to the t and dt over I times 1 plus n. So basically a sub n is gonna be, it's a constant, so it's 2 I pi 1 plus n, right? And integral from, well, the integral of e to the t is just e to the t. So we can evaluate this e to the t from negative I 1 plus n pi to I 1 plus n pi. So we just have to plug these limits over t, and let's just check what we are having actually. So basically a sub n is coming out to be 1 over 2 I pi 1 plus n, and if we talk about the upper limit actually, so it's e to the I 1 plus n pi and minus e to the minus I 1 plus n pi. So we are having that thing actually. So yeah, and again guys, you like if you are a daily viewer of my channel, so you are familiar with this. I'm sure about that. E to the pi equals e to the minus I pi equals minus 1, right? Using the Euler's formula. It's now for us it's just a child's play. So let's just not talk about that, because that's gonna just okay, I'm sorry, Euler, you just gave a lot of things. Okay, so it's and if we talk about this, so we can write this as e to the I pi times e to the I pi n, right? And minus e to the minus I pi and times e to the minus I n pi. So it's gonna be negative, and it's gonna be negative as well. So a sub n, well, we will be just switching the order of this part. Oh, let me just write that down. So it's 1 over 2 I pi to 1 plus n, and it's negative 1 to the e to the, negative 1 times e to the pi n, and minus negative 1 times e to the negative I pi n. And finally we are having our a sub n as e to the negative I n pi minus e to the I n pi over 2I pi 1 plus n. So this is your a sub n, right? It's pretty easy, it's not difficult at all. And now let's just talk about b sub n from that formula, from that equation. So so you just have to note that down. Actually, I need a couple of spaces. Where should I erase? Okay, I think I gotta erase these things because we have used. Okay, and I know about all the participles identity, so don't worry about that. Even if I just got forget at a moment, I have a paper in which I have written the formula. Don't worry about that. Okay, so our a sub n came out to be e to the minus I n pi minus e to the I n pi over 2I pi 1 plus n. Okay, and now let's just talk about b sub n. So b sub n is the same way, but you just have to replace the g of x with sine of x. And let's just talk about that. So basically, b sub n is 1 over 2 pi times integral from negative pi to pi of sine of x and times e to the I n x dx, right? So basically we just have to evaluate that integral. So let's just talk about that integral. So let's say that your I is the integral from negative pi to pi of sine of x e to the I n x dx, right? So for this integral, I'm just going to use the di method, plus minus plus. So I'm just going to take the derivative of e to the I n x, because it's pretty easy. And if you talk about the integral, so it's sine of x. So if you talk about the derivative, so it's e to the I n x, and with the chain rule I n, and the integral of sine of x is minus cosine of x, and again with the chain rule it's I n whole squared e to the I n x, and it's minus sine of x. This times that, and it's inside an integral. So your I is gonna be minus cosine of x e to the I n x, and this times this plus I n sine of x e to the I n x evaluated from negative pi to pi. And then since I squared is negative 1 and negative times negative is positive, so it's plus n squared times integral from negative pi to pi of sine of x e to the power I n x dx. Okay, and guess what? This is your I. So basically your I equals look guys, you know what, sine of pi or sine of negative pi will always be giving us 0. It means that this term is always 0, right? And cosine of pi and cosine of negative pi would be giving us negative 1. Yeah, because cosine of negative pi is just cosine of pi, because cosine of minus theta is cosine of theta, right? So from that way we can just understand that. And here we are having minus of cosine of your pi e to the I n pi, and the sign would be changed for the lower bound, right? And it's cosine of minus pi e to the minus I n pi, right? And we are having plus n squared I. So if you're gonna subtract both sides with n squared I, so that's gonna be giving us I 1 minus n squared, and it's gonna be giving us cosine of pi is negative 1. So it's gonna be it's e to the I n pi and minus e to the minus I n pi over, it's fine. And finally we are getting that I is coming out to be e to the I n pi minus e to the minus I n pi over 1 minus n squared. And if we divide both sides with 1 over 2 pi, so we are having b sub n. So this is your b sub n, guys. So we are having our a sub n and b sub n as well. So we have evaluated our b sub n as e to the I n pi and minus e to the minus I n pi over 2 pi 1 minus n squared. And basically 1 minus n squared can be written as 1 minus n times 1 plus n. And finally, it's time to use the final Parseval's identity, which tells us something great. Okay, I'm curious to use that, because it promises us that we are gonna get something different. So basically our final Parseval's identity says the sum as n goes from negative infinity to infinity of a sub n and the conjugate of b sub n equals the integral from 2 over L, 1 over 2 times L from negative L to L of f of x times the conjugate of g of x dx. So let's just talk about plugging all the things back into this equation. So your a sub n is e to the minus I n pi minus e to the I n pi over 2I pi 1 plus n. And look, you don't need to plug this directly back into it, because you have to take the conjugate of that. So if you talk about the conjugate, so you just have to replace I with negative I. So basically it's gonna be e to the minus I n pi and minus e to the I n pi. So, and it's 2 pi 1 minus n 1 plus n. So this is your left hand side for this equation. And if we talk about the right hand sides, so it's 1 over 2 pi from negative pi to pi of e to the ix. And since your f of x is, g of x is just sine of x, and we are not having any sort of like I in that term. So if we talk about the conjugate of g of x, so it's just f g of x only, because we are not having any sort of I in that. So basically it's sine of x dx. Oh my goodness, I need to change this board. I hate this one. The quality is quite good, but it's not properly stable actually. I'm so sorry, guys. Okay, so basically we are having this equation so far from the Parseval's identity. Okay, fine. And well, let's just cancel out something. We are just having some sort of cancellations from here, or let's just keep this up. So basically let's just evaluate this integral, because this integral is evaluable, right? So basically we have to evaluate the integral from negative pi to pi of e to the ix sine of x dx. And I'm not gonna use the regular way, the DI method. Instead, we know that sine of x is e to the ix minus e to the minus ix over 2I. So I'm just gonna plug this back into here and let's just see. So it's integral from negative pi to pi, and e to the ix times e to the ix minus e to the minus ix over 2I dx. And basically it's 1 over 2I integral from negative pi to pi. And if you're going to multiply this this e to the ix into this parenthesis, so it's going to giving us e to the 2ix minus 1 dx. Okay, so basically yeah, it's easily evaluable. So it's 1 over 2I, and it's e to the 2ix over 2I and minus x from negative pi to pi. Okay, and yeah, let's just talk about this. So if we are going to evaluate this, so it's 1 over 2I, and it's e to the 2I pi minus e to the minus 2I pi over 2I. And it's gonna be negative pi minus of minus pi, and yeah, right? Okay, look, if we talk about this one, so it's this thing, obviously, because when you replace x with 2 pi, so that's gonna giving us e to the 2I pi minus e to the minus 2I pi over 2I. And since sine of natural pi, like natural factor of pi, is always 0, so basically this part is gonna be 0. And when we just add this up, so that's gonna be 2 pi. Actually it is coming out to be 2 pi over 2I, right? And we just got rid of these 2's. Oh, wait a second. Oh, wait. Did I just messed up something? Or everything is fine? Hey, wait. Yeah. Pi plus it's. Oh, wait. Let me just check that out once. And we just did use of everything perfectly. Oh, okay. Perfect. I'm sorry. So yeah, it is coming out to be minus pi over I. And if you're gonna, oh, I think it's going messy. So basically we are having minus pi over I, right? And if you're gonna multiply and divide with I, so that's gonna be helping us to get rid of this negative. So basically it's evaluated to I pi. So this integral right here, I'm talking about this one, is I pi. So we just got rid of these pi's, and finally we are having this from negative infinity to infinity sum equals to I over pi. I over 2 actually, not pi. So let me just write that down. This sum as n goes from negative infinity to infinity of e to the minus I n pi minus e to the I n pi over 2I pi and 1 plus n, and times e to the minus n pi I n pi and minus e to the I n pi over 2 pi 1 minus n 1 plus n equals I over 2. Like, just imagine that this sum of this argument from negative infinity to infinity is being evaluated to I over 2. Like, that's amazing. Okay, so basically this 2I pi and this 2 pi's are constants with respect to n, so we can just consider multiplying both sides by 4 pi squared I. So basically the sum is gonna be e to the I n pi minus e to the I n pi e to the minus I n pi minus e to the minus I n pi, oh wait, it's e to the I n pi over, and it's 1 plus n times 1 plus n, 1 plus n whole square times 1 minus n, and it is coming out to be 4 pi squared I over, oh wait, I squared as well, because I times I, and over 2. Okay, so yeah, this 2, and we are having I squared is negative, so we are having negative 2 pi squared. And instead of just having negative over there, I think I should change one of these. Hey, wait, am I going right? Let me just check this out once, guys, actually, because I don't want any trouble with that. Yeah, I'm going perfectly. So we can just, yeah, so basically we are having negative over there. It's I squared negative, right? Negative 1. So multiplying both sides by negative, and even that negative, I'm just going to multiply that negative into this parenthesis. So basically this sum is going to be e to the I n pi, the switching of the order, and minus e to the minus I n pi times e to the minus I n pi minus e to the I n pi over 1 plus n whole squared, times 1 minus n equals, it's coming out to be pi squared, and actually 2 pi squared, right? Yeah. Okay, so let's just solve this a little bit, and let me just check everything is going perfectly, and it's been 26 minutes. Oh my goodness, I didn't mean, actually I just forgot that. Okay, yeah, it's been 26 minutes. Okay, so yeah, let's just solve this, the numerator argument actually. So we are having e to the I n pi minus e to the minus I n pi, and times e to the minus I n pi minus e to the I n pi. So if we're gonna multiply these two things, so that's gonna be giving us 1, and it's minus e to the 2 I n pi, right? And that's gonna be giving us minus e to the minus, actually 2 I n pi, and it's plus 1. So basically it is coming out to be 2 minus e to the 2 I n pi minus e to the minus 2 I n pi. Okay, so this we can write this one rather than this, right? So let me just write down, and dividing both sides by 2 actually. So finally we are having a perfect and crazy result after just solving all these things, and the numerator is gonna be 2 minus e to the 2 I n pi minus e to the minus 2 I n pi over 2, dividing that to both sides, and it's 1 plus n whole squared, and times 1 minus n equals pi squared. And just take a look at the result, guys. Doesn't it seems to be some sort of relating to the Gaussian integral? The way we incarnated the Basel problem from the Fourier series, if you might remember that, I have made a video. I made a video about that as well. So that's how we just incarnated this argument, that to the sum from negative infinity to infinity. And look, now there is some sort of trouble there, that n cannot be 1. Yeah. Oh, I think it's n minus 1, or hey, wait. Yeah, so n cannot be 1, because if n is 1, so that's gonna be something else. Yeah, you know about that. I'm not gonna just introduce over there. So n cannot be 1 because, yeah, but rather than that, it's perfectly fine. And oh, I'm sorry, it cannot be 1, as well as it cannot be negative 1. So negative 1 comma 1, because if we when you plug -1 over n here, so that's gonna be giving us 0 squared. And if you plug n equals 1, so that's gonna be giving us 0 as well. So we don't need 0 in the denominator actually, because that's gonna be just violating and destroying our work here. So we just need to keep that as exceptions actually. But other than that, everything is perfectly fine. Just take a look at this result. So yeah, guys, that's all. And again, guys, if you got to learn something out of it, please make sure to like, subscribe and share. And if you have any kind of doubt so far, you are free to ask me in the comment section. I'll be there to reply your questions. I'll be sure that, yeah, maybe I can surely say that you guys don't have any kind of problem with that. But still, if you are having some sort of problem, so I'm there to reply your questions, obviously. So yeah, good. I'm sorry. Okay, yeah, goodbye, guys. Love you. Take care, and just learn mathematics. And yeah, and you know what? Don't just forget about that. The thing that I have just explained. I've told you that I've got a crazy result out of this. I'm sorry, the Parseval's identity. So I think that's gonna be my upcoming video, or maybe next to next video. But yeah, I will be uploading that, and I'm requesting you to just come up to watch that video as well. Okay, goodbye, guys. Love you. Take care, and just enjoy your life with mathematics or anything else you love to do. Goodbye, guys. But please don't waste your life.